So we're going to solve problem number 13. As always, I'm going to highlight all the information that's important and what the question is actually asking. So 13 says solve. Now it says Kimberly is 3 times as old as her sister Haley. So I'm going to highlight Kimberly is 3 times her sister Haley. Right? So the first question says find the ratio of Kimberly's age to Haley's age. So ratio Kimberly to Haley. But then it says give your answer in fraction form. That's super important. Make sure you know what form they want it in. So to do this, I know that Kimberly is 3 times older than her sister. So I'm going to write Kimberly. I'm going to write the number 3. Which means that Haley would be 1. Because if we multiplied 1 times 3, that would give us 3. So Kimberly is 3 times as old as Haley. So now, to put that into fraction form, I'm just going to get rid of their names. So my fraction form for the ratio of Kimberly's age to Haley's age is 3 to 1. Because it asks for Kimberly's age first, that's what's going to go on top of the fraction. That's going to be our numerator. If it asks for Haley's age to Kimberly's age, then it would be 1 to 3. So our final answer is 3 over 1. If we were to write that in standard ratio form, it would look like this. So those two are actually equal, but this is their answer we're looking for. So now let's go on to B. B says, find the ratio of Haley's age to their total age. Give your answer in fraction form. So we're looking for ratio Haley to total age in fraction form. So now, I know that Kimberly is 3 times as old as Haley. So if I add those together, because those are each of our parts, I would have Kimberly 3 times, or plus, we're adding, Haley 1, which would equal a total of 4. So now I know what my total is going to be. So now I have to look. It's asking for the ratio of Haley's age to their total age. So I'm going to do the same thing I did up here, just with the total. I'm going to write Haley on top, because it wants that first, 1. And I'm going to write total on the bottom, which we just found, which is 4. So that's going to equal 1 over 4. So our final answer is 1 to 4. Now, I want you guys to realize that 1/4 is, or 1 over 4 is 1/4 of the total, because Haley is 1. So if we were to do this for Kimberly, it would be 3/4, because she is the other half, or the other part, to the whole of the total age. So I'm going to make this 3 quantity ratio into simplest form. So I'm going to look for a common factor in each one of the numbers that I could divide them all by to get our simplest form. So I'm going to start with 8 because it's the smallest. So I know I can divide 8 by 2. Which would equal 4. And I know I can divide 12 by 2, which would equal 6. And I know I can divide 16 by 2, which would equal 8. But even then, I can see that those can go smaller. So I'm actually going to divide it by 4. So if I divide 16 by 4, I get 4. If I divide 12 by 4, I get 3. And if I divide 8 by 4, I get 2. So at this point, I can see that I can't divide these all 3 numbers by the same thing any lower. So my final simplest form ratio is going to be 4 to 3 to 2. Make sure whenever you're dividing it, it's as low as it can go. You don't want to go, even though we can divide it by 2, that's not the lowest or simplest form. So make sure you're always doing the simplest form. So now I'm going to look at problem number 16. Again, we're going to be using equivalent ratios. But here it just says complete. So we don't know if we're making this bigger or if we're making it into its simplest form. So let's take a look. This is a 3 quantity ratio. 1 to 2 to 5. And over here it has blank to 6 to blank. So if I compare 2 and 6, I immediately see that we're going bigger. So I'm going to try to figure out what can I multiply by 2 to get 6. So I know that I can multiply 2 by 3 to get 6. So whatever we do to one factor or one term in our ratio, we have to do to all of them. So now I'm just going to multiply all of them by 3. So 1 times 3 is 3. And then 5 times 3 is 15. So that would be our equivalent ratio. We weren't going simplest form in this one, we were just making it bigger. You always want to make sure to use the clues that it gives you to solve the problem. So for this section, see if there's any 3-term ratios in your project. If there are any 3 quantity ratios, make sure you either put them in simplest form or you make them bigger, depending on what your project is. Make sure that if in simplest form, it's the simplest form you can get. Don't make it just a little bit. Don't go halfway. Go all the way down to the simplest, easiest form you can. And if you're making it bigger, make sure that you're doing it to the correct, you're multiplying each one of your terms to the correct multiplier. That way you get all of your correct ratios.